Welcome to our Saturday stream. Completely new project today. I kind of paused the switchwire and it's kind of done. So let's return to our good old V0. It's kind of like upside down at the moment. I was trying out already a couple of things. So what we want to do is basically to add LEDs to the underside today. We did the same with the Enderwire, and I kind of want to copy the concept because I kind of like how it looks to just have like the desktop illuminated below the printer. And yeah, that's kind of like the goal for today. Depending how quick or not quick we are, I also have this like lightweight x-axis that I want to add. Let's see how fast we are. I'm actually not sure if we need any custom printed parts for that because I did not print any. Which I just like thought about right before the stream, but it looks like it's pretty much compatible to just using a normal extrusion. So let's see about that. But yeah, the first step would basically, or like first like task we have today, is to replace the bottom panel. What I did so far, so we of course want to use like the LED strips, and yeah, so basically what I did so far is I created a replacement bottom panel, which is just like some acrylic glass I reused. You see it's like a bit scratchy and everything, so it's not perfect. And actually like while cutting it to size, there's a little crack now here, but so not perfect, but yeah. Good enough. Good enough. So basically, this will replace the black bottom panel here. And what I then basically figured out is there's quite a lot of space. So there's like roughly like 1.2 centimeters of space. These are also still the V0.2 skirts, not the 0.2 R1, which are actually a tiny bit higher. So for the R1 revision of that printer, there's even more space. But basically what I want to do is I want to make use of this space and add this light channel here. So that kind of like goes here more or less, and that goes on top, and then we'll have LEDs running inside here. So that's kind of like the main goal for today. We have to drill a couple of holes in the acrylic. We have to install LEDs in that channel. It's actually, I think, what we should start with. We also need to figure out how to connect the LEDs to the printer. I think I figured it out, but I'm not 100% certain if what I thought or if what I think will work will actually work. So let's see about that. Yeah. Let me just quickly show the back, and maybe let's also remove the door so that's not in the way. Kind of like here. So basically the challenge with connecting the LEDs, so nice and small, like compared to the Enderwire. So the problem, basically the problem is kind of like a very hard word here, is that the designated LED port, which is this one here on the side. This one is already taken for the LED on the Kirigami bed. So we can't use it, of course. There are a couple of options that we can use instead. One is actually the plug that's here. This one is the little button I added here. So this button goes to this plug. And this one is actually like labeled servo, but I think we can move this one to a different port. One thing I was looking at is the TH0 port here, which we don't need. This should be free. And then basically this becomes free. And here we have the very nice situation. We have ground, we have a GPIO pin, and we have 5 volt. So we can directly plug the LEDs in here. I also checked that the SKR Pico here, according to Google, we'll find out if that's true, has 5 ampere available on the 5 volt. The reason is that there are some configurations where you can power the Raspberry Pi directly from this plug here on top. So basically the SKR Pico can provide enough ampere for the 5 volt to power the Raspberry, which we don't do in the setup here. But this basically allows us to use all the 5 volt juice for LEDs. We quickly have to run some calculations. Actually, I think we will not use too many. I think it's like maybe 40 centimeters. So the strip I have here is 96 per meter. So it would be like something 40-ish LEDs. And I think they use 0.06 ampere per LED. So it would be, yeah, like 2 ampere tops. So should be fine if we put this directly onto the SKR Pico. So that's kind of the plan. So what I would do now is let's first install the LEDs in this setup here. We will need to have some JST connector here that we want to, or that we don't use to put it here. We have to basically, because we have this 90 degrees bends here, we have to basically cut one strip here, one strip here, and one strip here, and then solder them over the corner. And yeah, heated inserts, we also have to add four pieces here. And then, yeah, that's pretty much it. So let's start with that, and then let's figure out the electronics and then the configuration. So I just kind of like put this back up. And it's amazing how much space I have on the table today with only the V0. Oh, there's some stuff. Some dirt out of the printer. Cool. Then let's start maybe with just the heated inserts. Then we have that out of the way. So, let me see, I should still have some. Oh no, we only have 2 left. Let me see. This is a hardware kit from the Enderwire, and there we have plenty more. Let me just refill my stash here. So for the Enderwire, I was not quite happy with how the LED shuttle is designed. I mean, nobody to blame but me. But they're basically, the LEDs are not facing down. Like here we are directly like facing the LEDs towards like the tabletop in the end. But for the Enderwire, I basically faced them sideways and then like reflected the light down. And that works. It's just like, it's not super bright on the table. So this is kind of like an iteration on that. So that basically like we shine the light directly on the table. I don't think we need a lot of diffusion here because like there's some distance between the LEDs and it will also shine through the acrylic. So it kind of like bounces around a bit. So it should be super fine to just directly shine the LEDs on. I added a chamfer here around the inside. So if we need more diffusion, we can print like transparent PETG and put this between the acrylic glass and the channel here. And I also was thinking about, because this is like a little bit scratched up here, like can't really see it on camera, but there's some scratches here and there. maybe I just frost that I just use like a very fine sandpaper, like a 600 or 800 or something like that, and just frost that. And by the way, I'm very proud. Like it's kind of like square and straight, and I cut this by hand with like super bad tools for that. So I'm really happy that it fits and it's kind of looking kind of okay. And there's still some marker here on the edge, so we'll clean it up. Cool. Let's put in the heated inserts. Yeah, that starts well. And the last one. Trying to make them like super flush. Actually, like I now noticed like this part is a little bit warped. Like I printed in ABS because the LEDs get quite toasty. No, it's not too bad. Like it's a little tiny bit warped. The LEDs get quite warm, of course, like while they're in operation. So I didn't want to print this from PLA. But then the Enderwire is only like open. I don't have enclosure for that. So printing ABS on that's always a bit funny. Cool. So then this is that. Then let's quickly check the strips. And let's let the iron cool down so we can change the tip. So basically, we need 3 strips, right? So we need 1. So firstly, we need to get rid of this. Like that's not something we need. And then basically, I wonder how it's best to kind of route it. I think it's quite okay, or like best to, if we kind of put it end to end here, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 LEDs. So this is like 28. And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So maybe get away with 12 here. So it's like 14, 14, 28, 30. That's 40 LEDs. So let me just check my math. But if we have 40 LEDs and each LED takes 0.06 ampere. Yeah, then we have 2.4 ampere at max brightness. Which is half of what the Pico can deliver. So it would work out perfectly fine. Okay, so basically we have to connect the 2 strips, but we also have to create the JST plug on the end, which I could have like already taken out, but so basically we need 1 socket, and I added like a little like hole here for that. So this should like snugly fit in here. Most likely it's tapped too tight, so we need to work a little bit on it. Yeah, it's a bit too tight. We have to like file away a bit. But basically the socket goes in here. Now we have like the 3 pins that go directly to the strip. And I think that we have like quite a bit of space here to just tuck some cable and stuff. So yeah. Now say let's get rid of that end piece here. Oh, here you go. And then we can remove those cables. Very good this way. Not hot, but it's a bit warm still. So let's get this back up to temperature. Oh, cool. Then let's just see if we are hot already. Oh, a bit too much. Here we go. I think we don't need like a lot of length for the cable there. Like basically it's just from here to there, right? Because like we push the strip all the way down. So if we use like what? Not making it easy for me. Something like this cable length wise. Let me also quickly cut that for the other cables we need. And now we have one black, one red, and one blue. And blue I just use for the data. Let's quickly throw some tin on the ends first. So then let's start with the left one. Bit of fresh tin on the tip to get this started. Could have also removed the isolation from the other side, but that would have been too easy. Let me see. I also have some heat shrink somewhere. So what I always like to do is like use bit of heat shrink. I mean, technically you can do it on all three, but I like to do it on the center one, just like to 100% ensure that there's like no short between them. And then the center one is already good enough. Let's also add a bit of tin. Oh wait. Also add some tin to the ends of the wires. Totally forgot. And with those, you always have to be quick. It's a bit too short. If you heat it too long, it always melts the connector. I'm very bad with that. Oh wait, we lost the heat shrink. Did it happen? Did I melt the connector? Yes. Yes, I destroyed it. Oop. Okay. When the pins get too warm, you always pull them out. Let's do the following trick. It doesn't work with JST. Usually, like if you have like a populated plug and you solder it, you can put it together, and then like the cables on the other side act as a heat sink basically. Then this doesn't happen as easily. Yeah, let's try one more time, and otherwise we quickly crimp the cable we need. We crimp the cable first. I really don't like the soldering to JST. Let's see. Yeah, seems like we managed. Let me quickly check. Yeah, that works. Wait for that until we know that. I mean, technically we can already. Yeah. Perfect. And now basically I have my mental piece that nothing here can short because the center one is isolated. And then it should be all fine. Cool. Then how about we put the strip in here, then we can, or we already counted 14, right? So 14 LDs we need. on that first segment. So this can basically go more or less all the way to the end. As 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so 14 we cut it here. And we have a bit of wiggle room left and right. So that's quite good. Let me cut it. Trying to cut the pads in the center. So it would go in here. And then we can kind of like make a small loop with the cables. And the JC goes through here. Let's actually like fiddle it already in there. It's a bit too tight, we said, so let's just work a bit. Especially on the overhang side. I always design them too small. I think it's also like a left-right problem, like not necessarily like a bottom-top problem. Let me quickly grab a different file. Give me like 20 seconds and we can file left and right because this one is too big for that. Right back. Here we go. This one is square, so allows me a bit to file here on the sides. And also make sure that the corners are properly square. See if it now fits. I should also move the camera a bit forward. I don't have my hair all the time in the frame, hopefully. Yeah, it's not wide enough, by quite a bit. I wonder how that happened. I think I just used like 0.2 millimeter tolerance. Let's make sure that. See it coming, that will be like way too wide in the end. And then we need to use glue. That's not easy to get in there. Yes. I think from the height it fits in, like you can kind of like angle it in here. So it's really just like left, right. That's not good. Let's see, step by step. I don't feel like it's like a lot that's keeping us from putting this in. So So let's try it from this side. All right. Ah, success. See if we can replicate it from the back. Yes. Okay. Success. So it's in. Let me quickly clean this up. So then this works, and we can put this in, and we just have to like kind of like make sure that there's a little bit of like a loop with the cables. And the next step would now be, we set 12 LEDs, right? In this direction here. You kind of need to keep this side free as well. I mean, technically we can also have now this going all the way to the end. Then it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh. So if we said this one would be shorter. So if we only do it till here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, okay, perfect. And we have 3 times 14. That's good. So let's cut that here. And let's actually push it back out here, and then we can like solder those together. So basically we need just like a really short loop, right? Because they kind of go like this. So we need a really short loop to connect the two. I think something like this should already be enough. Maybe we can try to solder it like vertically a bit, that like stands out vertically. Let's actually like make this a tiny bit longer, because I'm an expert in doing it too short, or like having the cables just ever so slightly too short. Okay, so maybe we can just resolder it like not like this, that goes out towards the end, but like to the top. And actually, like looking at this, like we need different lengths, right? Because like this needs to go here, so this has quite a bit more distance than the other two. So the blue one is super short. What we have here for black actually should be fine, but the red one, and it could work, but let's cut the red one a tiny bit longer. Okay. Let's do it like this again. And for the red one, we want to have a bit long. Cool. Let's do both sides right away. Let's also pre-tin the pads. A bit more here. So. Then the first step is the 5 volts. Let's see. I don't think this works. Putting it vertically. Yeah, like we have to do it like this and then bend it over. That should be fine. Okay. Just checking that it's long enough, but yeah, like the red one can reach over there, so it should be fine. We already cut this strip, so now we need to pay attention with the direction. Like there's a little arrow on the sides. So this needs to go here. Bit closer. Let's see if we can manage to connect the two. Here we go. I remember the first time I worked with those LEDs like long time ago, like 2015 or something. Like I really struggled putting them together. It was such a pain. But I also worked with the 144. Like the first time I worked with them, I used the 144, which have like even smaller pads. Like the higher density of the LEDs, the smaller the pads become. See how do we do that? Something like this works, right? And we have to do one more. And I guess this one would also be a strip of 14 then. So we kind of make use of the full length. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So it's this one was also 14, all right? 3, 6, 9, 12, 14. Yeah. Wait, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So here. Perfect. And let's do one more connector. And then the hardest part's done, I think. Hopefully. Okay, let's see. Can I use those? Like I cut them? I think the blue one we can use. The red one is a bit too short. Perfect. So let's also like quickly strip the ends, put tin everywhere. And then technically the next thing we need to do is the cable to connect to the main board. Oh, it's a bit short. Here we go. Oh. Let's start with the 5-volt again. I was a bit stubborn. Let me get just a bit of tin on the tip. It always makes such a difference, like if you have a bit of tin on the tip, like it's so much easier to melt the solder. We already cut that. Again, we need to pay attention with the direction. Put that here and that here. The blue data is a bit short. Let's see. Hopefully it will reach. Let me actually do it this way. Cool. So technically it should already work, right? So we can place it in here. Yeah, and it looks good. Let's start with the end and then like walk our way around. Let's see if I get this off. Let's try a different corner. Very sticky. Here we go. So that's the first one. Actually, now that I put this in, let's first test it actually before we glue it in, because we now have to fix the, or like do something with the solder joints. Like it's impossible when it's glued in. So it's best to first test and then glue them in. As I glued the first one in. Cool. Then let's wait with just sticking them in. Then let's focus on a JST connector. So basically we need to make a custom cable. So let's check out how long that needs to be. Save this. Do the usual, just like all the trash in on one side. Let's see. So basically, this will be somewhat here. So basically, we just have to go from here to wherever we want to plug it in. Let's quickly check the pin out actually. But my favorite spot is still this one. That would mean that we have to remove the housing from that white cable and put this over here. And then this cable would have roughly, kind of needs to be here, goes through here somehow, and then needs to go over here. So let's add like another little bit. So something like this would be our length. It's way too long. I would say let's put actually connector on one side. Oh, it's way too long. Almost double. Let's put the connector on one side, and then we can plug it in, kind of install it already. No, it's fine. Let's not do the connector. Let's do the connector. It's I guess the easiest. Put it over here. I do have some cable. We can recycle, like old LD installation. Let's just make use. It's exactly the same wire. Let's keep it a bit shorter right away. Yeah, something like this. And there's also some black we can use. Oh, I guess it's the last bit of cable we need. Now it's time for our favorite JST connector crimping. Haven't done it for at least 2 weeks. Absolutely missed it. Oh. I always forget which size I use on those crimping pliers, but I think like the medium size worked always quite well with those cables. That was quick and easy. That's how I like it. So the order needs to match what we did with the LD strip, of course. So looking at that, that would mean that black goes in on this side. That's in. Blue is in the middle, of course. And last but not least, red. Let's give them a quick tack test. They are good. Cool. Then for the other end, we need to figure out which connector we use on the main board. And we also need to figure out the order of the pins on that connector. So let's jump quickly to Chrome and to the pin out. So, no, not mini, SKR Pico pin out. Wait. So, if we would have been smart, we would have checked the configuration. Let me actually see if I have a backup. Otherwise, we have to quickly turn on the printer. So, give me 1 second. I'm fairly certain that at one point I made a backup. Okay, maybe let's quickly turn on the printer. That's a bit of a mess. Okay. Okay. We didn't change anything on the electronics, so there's nothing that can go wrong. Nevertheless, here you have the magic smoke cam. And we didn't make any changes yet. Yay, success. So that would basically mean that we need to reconfigure. Let me make a bit more space here. We don't need to solder anymore, actually. So let me turn off the soldering iron. So at the moment, this plug here is used for this like rear button, which I'm not quite sure why I did that, but that is the one I picked. And then my idea now is to move this over to the TH0. So what we need to see, or like what we need to check, is whether we use the IO27 pin for anything in the configuration. I think it should be free because the hot end thermal probe is connected via the breakout board. So this one should be free. So we should be able to reconfigure this one for the button. And that would open up this one, this plug here, which is labeled servos for our LDs. So basically the benefit is we have one, it's kind of a bit hidden here, but we have one GPIO pin, which is GPIO pin 29. We have 5 volt and a ground connector, which is exactly what we need for the LDs. Like the order is different than what we had on our side, but it doesn't really matter, right? We can just swap the cables in the connector. And I also checked before the stream that this 5 volt pin here is connected actually to the 5 volt it's labeled laser, but they also suggest you to power the Raspberry via that pin. So that means they're all kind of like all the 5-volt output pins are connected. So they all can draw this 5 amps, which we now will use partly for the LEDs. Yeah, so basically we need to check if the IO27 is free. If yes, we reconfigure this plug over here, and then it should already be kind of okay. So the thing is, like, it will be interesting to see, but from my understanding is you don't need any special pin for driving the LEDs. Because here's this RGB header, right? This is this one here. And this one has the IO24, ground, and 5-volt. Like the order of the pins is different, but this one is the official plug to use for RGB LEDs. But I think that there's nothing, well, like I don't see what would be special about the pin 24 that you can only use this one for RGB. So I'm pretty sure that we can just configure the servos header here, like this plug here, to just have the same functionality. It's a nice thing about Clipper, you can just change stuff and it just works, mostly, most of the time. Okay, so wait, we were looking for, we want to check IO27. Let me quickly see. Yeah, it's like GPIO. So we are looking for GPIO27. Yes, this is mentioned here for the sensor pin. This is thermal sensor. But then also LDO picobellically overrides the setting. I'm not quite sure where this would be. So let's quickly figure this out, how this is set up. I think this was a separate config file. No, it's not. So it must be in printer. So let's search for sensor. So we find here in this extruder section, which is the GPIO27. Heater bed is the same. So here's this override. So here it now says umbilical, which is like the breakout board, GPIO29. So the thing is that I don't understand is why we have to override that here. Because most likely if we now try to configure something else on that pin 27, it will tell us that it's not possible. But we can quickly check that, right? So somewhere we have this button configured. Let's quickly see where I configured this button. It's a bit of a mess. Let me actually like delete the backup files. Oh, it's not that many backup files. It's a lot of, there's another backup file. A lot of files. Filament runout, let's see. Yeah, exactly, here's the G-code button. This is like the plug that's currently occupying the port we want. Let's just try what happens if we configure this one to 27 and say save and restart. If it complains that it's like double allocated or something, or whether it's... Wait. Oh, so basically what just happened, it works, but it immediately started to home, and I'm not quite sure why it now started to home. But I think the button here on the back, if you press it, it will home the printer. It will like initiate a filament swap. So basically we'll home the printer, move the printer to the front. So it triggered the G-code button here. So let's see. So GPIO27 was triggered. Let's see. Why would that be triggered? Let's see, maybe we can leave the GPIO 27 alone. Let's quickly see if we find another plug that we can use. So the servo we want to use. I mean, there's this laser plug down here, which has the GPIO 20. Oh, you don't see it. This one here has GPIO 20, but this is partly blocked. Partly blocked from the USB-C cable, if I see that correctly. I don't think we can... we could squeeze it in there, I guess. I mean, it would be also fine, and we don't... If I don't have to figure out now why it triggers automatically, because there's nothing plugged in at the moment, it's plugged and it triggered the sensor. Most likely it has something to do with pull up, pull down stuff. Let's try the following as the last thing. Let's quickly copy over here, this one. Let's quickly copy over those. From the extruder section. And let's just put them into the extruder directly. So let's just comment that out. We now need to also check the heater pin, so this also needs to... Let me just quickly mark those lines. It's super professional. And then pull-up resistor we don't have. So let's see. So now basically we don't mention pin 27 here at all. Yeah, it again starts to home. Potentially GPIO 27 has like internal pull-up or something. Let's quickly figure out what this little thingy means. So clipper config pull-up, pull-down. So this one means hardware pull-up resistor should be enabled. If the microcontroller supports pull-down resistors, then an input pin may alternatively be preceded by... It's interesting. I mean, we can try what happens if we try this thingy there as a pull-down. And see if it starts to home again. Yeah, it does. This is weird. Okay, then let's try what happens if we keep it as is, but we use GPIO 20, which is the one we can also alternatively use. And let's also restore then the configuration we had here. If I find it again. Here. This comes back. And this we remove. And then this comes back. This comes back. And this comes back. Save. Oh, we also need to restart. Oh, yeah, now it complains. GPIO, oh no, wait, GPIO 20 used multiple times. Let's see where we use 20. For the PCB fan. For the PCB fan. Oh yeah, indeed. This is IO 20. We also have IO 17 up here. Well, it's a fan. Like, technically we can use this as an input. So I feel we really run out of pins here. I mean, there's the IO 23, but this one is like this plug is paired with a 12, 24. Always have to scroll over 12 and 24 volts, so this doesn't really make like a perfect button pin. And then we have this one here, but this one has like this weird P_S pin where I'm not quite sure what this is. So I think the 27 is pretty much the last one, and the 23. But 23 could also be doing some double duty somewhere. Can I? No, it's an image. It's not a PDF. Oh, it's a shame. So we need to check then what causes that 27 is automatically triggered. I mean, it could be something with this, just hardware-wise with this pin. I mean, what we can also try, we can just try to invert it, right? So if we just leave it as is here, right? It's now all restored. So what we can do is we can add this exclamation mark here to invert it. So basically, let's just comment this out that we don't trigger actually something, and we can just see this output. Oh, we forgot to change the pin. So this is 20, no, 17, you said, right? 17? 27. 27. Oh, see? Okay. Doesn't home, but it also doesn't do the button. Oh, yeah, it's not connected to that port, of course. So I think maybe I have some like general like logic issue here. Because the thermistor pin, of course, the thing is like for thermistor, right? The thermistor is just a resistor in between those two pins. And the resistance basically indicates the temperature. So it could be that IO27 just is always like... I don't understand enough electronics. So maybe it's not smart. Because basically if I would now connect it to this pin here, and I press the button, I short the two pins, right? So potentially I just can damage something there. We can't use X, Y, and Z because those pins are kind of like like the Z is physically occupied, but X and Y is because we have the sensorless homing. Those pins are still in use basically, although they're not physically connected. Now then, the only thing is the IO23. And what we can do is actually we can split it over two plugs. It's a bit ugly, but it works. So we use the IO23 as it's after 21, and then the ground we take from the next plug. It's a bit ugly, but it works. So let's quickly check if we have the IO23 available, if that is used for something. GPIO 23. Yes, heater pin for the extruder. Where would that be? Oh, also here, heated bed 21 and heater hot end is 23. I mean, they are not physically used. It's just like this weird thing, like how they configured it, that like they put it here and then they say like here, like, oh yeah, but later we change it to something else. So what we can do is, let's just check for heater pin. So heater pin is umbilical GPIO4. Let's just put it directly that we don't use, oh wait, it's a heater bed. Let's see, do we have this like, oh no, the bed actually like goes via the thing. So the GPL21 is taken. So this one is also taken. GPO21 is taken. Let's quickly check if 29 is available, because if we don't have any GPO left, then this is like very short. It's umbilical 29, so that's a different one. So 29 is actually free. 29 is actually free. I mean, not really, because at the moment we use it for the button. Wait, where's the runout? So this was 29 initially, right? And we didn't have it inverted, we had it like this. Let's quickly check if it still works. So if I press the button, yeah. Oh, yeah, you see it in console. Like it says the eject button. So that works. So maybe we have to sacrifice this button then. I kind of use it sometimes. But what we could also do is we can have the, I mean, we still have the Raspberry, right? I don't think I have the Raspberry configured at the moment. Oh yeah, I do. So what you can do in Clipper, actually, you can configure the Raspberry as a MCU. So you can also use the Raspberry GPIO to trigger stuff. So technically we can also do that. Then I would remove that button for now. And let's just see if the LD works. Because if the LD don't work, then we don't have to worry about anything, basically. So let me just comment out this entire section here. This is all gone. And instead, what we do is we search for NeoPixel. Exactly, this one is the one we already have, and then that's just the output pin. Oh, we could actually check if the umbilical still has open ports, but let's keep it simple. So let me just copy that. How many LDs? Let's just set the chain count for 1 to 1 by now. For now. And then this is GPO29. Let's double check. This one is 29, yes. And then we can just keep this as is for now. So let me quickly unplug that button there. And then we say save and restart. Cool. Okay, now technically we can plug in the LEDs and something should happen. So let's quickly just shut down the printer, turn it off. I don't want to work on it when there's like power. Let's create the cable and see if it works. So, but then that gives us also like the order of the cables, right? And that would be, plug is oriented like this. So the top one is yellow, not yellow, blue, and then the red is in the middle, and grounds on the bottom. So what I would like to do, always like, not always, but like start doing that recently, is let's just braid those 3 cables together. And it's kind of like more cohesive and stays together. Oh, you don't see anything. Amazing braiding skills here. Wait, something's wrong. So, full focus. All right, let me quickly start over. This is not very nice. Not very even. So let's start again. Try to make this a bit more uniform. This is not my core skill set for sure. So basically we said blue needs to be on my left, red in the center. So it would kind of be like now the case. Sorry, you don't see it. But yeah, that would now be the end. So I would do now. It's not super like uniform, but it's good enough. I have some really cheap cable ties here. I mean, cable ties are all cheap, but these are like especially like poorly made. So let me just use this to like kind of like secure it. I'm not feeling bad for using them for like 5 seconds. So let's just make sure this is all like kind of the same length. And now we can crimp them with the extra challenge of the braid. So here we go. Start with black. Yes, first success. Let's do blue next. And one left to go. Perfect. So let's double check. With this facing up, the blue one goes here. And the red one goes to the center then. And the black one to the side. Correct? Yes, correct. Cool. Let's remove this temporary cable tie without damaging one of the wires. And here's our cable. Without obvious braiding errors, so I count it as a success. Let's quickly check. So if I now plug this in, oh, what did it do? Oh, wait. We need to pay attention. The two ends are different. They're not the same. So this is kind of like dangerous, quote unquote. It is actually. Yeah, you have to pay attention there. That's not ideal. So basically this side here, right, has the blue on the left, and this one has it in the center. If you would have been smart and like looking ahead, like we should have, and we could technically still change that. No, that's fine. Maybe we should glue one side into the socket then, because like I'm the first person who like mixes it up. Let's at the very least mark one side. Hopefully this will give me pause before plugging it in. So basically the side with the marking is the one in the main board. And if I plug this in here, we have blue on the side of the stepper drivers, which is correct. So blue is IO29, is this pin here. 5 volts in the center, which is correct. And we have ground on the side, which is correct. So this one looks good. If we now plug this in on the LED side, which is a bit hard, but once I still like melted the pins a bit. So this will give us red on red, blue in the middle, and black black. So this all looks fine. So this looks all fine. Let's see. Let me just again like do a little bit of a cleanup. So like move this a bit to the center. We have tons of space. So technically what should happen, if I now turn this on, the first LED should become green, I think, or something like that. Yeah, later we have to put this in the housing here, but like for now it's fine. If the first one becomes green, we can like, I would just do it like in steps of 14, just seeing if everything works. This one is not dangling here, but that's fine. Like it's not connected to anything on either side, so it's fine. Are we certain that this will work? I think it will. Let me just double check the wiring one more time because I'm a little bit obsessed with that stuff. Blue is on the stepper side, that is correct. Red is in the center, that is correct. And ground is on the right-hand side. And I'm not screwing it up, that is the heated bed, is this block here. And then above it, we have the servos pin, which is what we are using now. So I'm expert in killing printer mainboards. So here it goes. I mean, it didn't explode. That's a good sign. Let's wait if the LD wants to come to life. Thinking of it, the configuration we did can't work. Oh, it worked. You can't see it on camera, but it's green. Like very faintly green, which is exactly what it's supposed to do. But did I change the name of that? Wait, let's quickly search here. Oh yeah, like we now have 2 sections NeoPixel backlight. So maybe I overrode the one from the front. Let me see if I turn it around. Yeah, this one is off, so we now overrode it basically because the 2 sections. Let's call this underglow, and then both should be green. Let's see. Let me just peek around. Yeah, this one is now on. Like, in case you don't believe me, you can't really see it. It's at the end of my camera reach, but both are now green, so that works. So the lesson we learned today is if you have exactly the same section twice in Clipper, it will combine them. Which is interesting. Like I did not know that this was a thing. So let me quickly check. Hey there. Good afternoon or good evening. Cool. Then let's quickly try to increase the amount of LDs, right? So technically we can, with this faint green, we're also not pulling too much power. Hi there, Alex. Yes, my software is quite outdated. But here's the thing, every time I update Clipper, something breaks. So never touch a running system. Yeah, I don't know, like it's just, yes, I should, but I'm always afraid of that. Mainsail is up to date, so you know, there's something. Yeah, let's quickly check. So if we now set, where is it again? Here. So this is now chain count 1. Let's just set it to 14, quickly see what happens. I think we have now like, what did we say, like 42 in total or something? Well, it does something. I'm not sure if you can see that, but it's kind of like rainbow. Rainbow. Let's see if that is a hardware issue or whether we have. Yeah, there's something wrong. The last one is correct. No, it's not. Now there's supposed to be blue, so every second is correct. Oh, this is odd. What could that mean? Oh, I know what happens. I know what happens. These are RGB. They're not RGBW, but I think the one in the front is RG. Yeah, exactly. So here it's GRBW, but these are not GRBW. So basically, the byte that is sent to like color it is offset by 1. So I think if we say this, save and restart. Yeah, exactly. See, now it works. That's also why we told it to light up 14, but it ended up lighting up 17, 19, because like basically each of them got 1 extra byte. Perfect. So hey, that's good. Then we had 14, 28, 42. Yeah, 42 in total. That's basically as many LEDs as the Enderwire has on like 3 times the length. Perfect. All green, all working. Then I guess we can glue them down and start prepping the panel. Cool. I'm still low-key a little bit concerned about the power draw. Like technically, like we're not like even at half, but it's still like a bit sketchy for me to pull that much power from the mainboard. Will you print in the dark from now on to enjoy your underglow? Yeah, exactly. The goal is that it's so bright that even with the video light, it's still visible. That's why I have so many LEDs. For the Enderwire, I had 30 LEDs per meter, and this is like 96 LEDs per meter, so it's like 3 times the density, and it's like also like way less space. So I hope this will be much brighter than the Enderwire. Let's see. Yeah, this is really bright. I don't think I have to max them out. See, that's like even with the video light I had, right? Like it's super bright here. You still see it like really nicely. It's like most like even just like the question is like how close is it? But I think it's like something like this is like the height in the end. Let's see. Cool. Let me quickly shut it off, and then we can like glue everything and drill holes and like do all the fun stuff. And off. The only downside, Alex, not sure if you were already here, but I'm running out of GPIO pins, so I had to remove my eject button for now. We have to find another way to connect it. Most likely I'll connect it to the Raspberry. Okay, here we go. So, where is my tweezer? Let's try to peel it off. This is almost the worst tape backing I've ever had. You need another NPU, maybe Raspberry Pi Pico. Yeah, that's one option. But I think I can also just use the Raspberry GPIO because I have the Raspberry already as an MCU. And then I can just use the GPIO of the Raspberry. That should also work. But yeah, Pico is also like a valid option. I actually ordered like a bunch. I needed one for the resonance tester for the Enderwire. And I ended up ordering like 5 or 6 in the end. And it's really bad. Like, it's just like ripping. Let's try this side. Yeah. Almost ripped off the pad. That's not ideal. Here we go. So, I hope the pad is okay, but it should be. Try to. Bit of a squeeze here in the end. Here we go. Maybe 1 LD less would have been fine too, but see if I can. Yeah, that's okay. Let's not play around with that too much. Perfect. I'm peeling off this protective film. Like, this one's really bad because it's just like, it just rips. Like, this is like really bad. But there's also I had it somewhere. The VHP tape is still the worst by far. The VHP tape is like, oh, there it is. Like, this one is like, it's absolute worst. I hate peeling the backing off from that so much. Cool. Okay, we have this installed. This is the glorious handmade panel. Oh, I also have to put this one here, and we need the dab of glue to hold this in place. Let's just push it out a bit, and we can just put a little bit of super glue there. My all-time favorite. Just a tiny bit. Perfect. Now this can dry. And in the meantime, we can mount this. So it will be mounted, like, it's a bit hard to see, like, you see where the gloss ends, the reflection ends. So basically the idea is to mount this a little bit more towards the front than the back, because in the back we also have the AC wiring here. So we need to make sure this doesn't overlap. I agree regarding VHP tape, yeah. The only way to kind of get it off is like with a cutter knife, like to kind of like peel it slowly, but it's like, it's really, I mean, again, most likely just means it's like really strong tape. But yeah, it's not a fun user experience. Where do I have that? Here. I also printed this little like alignment helper. This is like a ridge over here, so you can just push it against the plate, and then we can put this here. And this is basically now perfectly centered how we want it. The only thing I didn't consider is now how do we how do we mark the holes? I guess we have to do it from this side. Let's see. That's a bit of a challenge. And also, it's super important if it's not like 100%, right? But I think something like this. Let me put some marker there. Now we have 3 holes. But that's not all we need to drill, right? We also need the mounting holes in the corners. Looking at those, because I only took out a 3mm drill bit now. I'm sure if those are a bit more, but should be fine. Let me see, is this dry? Yeah, it's dry. Okay, that's... So the thing is, like, my hand-cut panel is, of course, not perfect. So I just hope that it's good enough. It's not 100% straight. Like, we can always like work on it a bit more. But getting it to this point was quite painful. Because I don't have a jigsaw. That's like one thing I need from time to time, and I never got around buying one. And it bites me every time. So let's carefully flip that over. Let's just quickly check. So this would be the orientation it needs to go in. And that goes in. But that's not 100% aligned with the holes. So this one is a bit off. And I'd rather go with the drill holes here, to be honest, for marking. Like, these are fine. This one is a bit off, which is weird, but that's just... I mean, worst case, we can just drill it out like as a 4mm or something. If it doesn't fit 100%, like, we can just drill this hole a bit bigger. That has no impact, I think. So these are the holes, and then you see like it's like shifted a bit to the front. So this will be like this basically. Yeah, and then also like I mentioned in the beginning, like these are still the 0.2 skirts, not the 0.2 R1, which are slightly higher. I can't remember by how much. It was a couple of millimeters. So there's even more clearance. Maybe use a bit of VHP tape to hold it in place. That would have been a good idea, but then I have to like peel off the backing, and we just discussed how horrible this is. No. This is my OG IKEA luck drill surface. Let's see. Let's just start with the outer ones, I guess. That was that one. Wait, I can also give you like a maybe nicer angle on that. not quite spot on. Most likely we'll have to drill those out in 4 millimeters. If I wouldn't know better, my drill bit looks a bit... No, it's center. It looked like a bit crooked. Oh yeah. They're all a bit off. This one particularly. Okay, let's see if we can mount it. Or would I have to get out the bigger drill bit right away? Let's go like here. Oh yeah, that's not that's not gonna happen. 4 millimeter might not cut it. Like this one particularly is just a bit off. I mean, you can see it, right? That's not gonna work. Let's quickly drill this out in a bigger one. I mean, it's like left-right constraint anyways. Then we quickly get a bigger drill bit. Right back. Okay. 4 millimeters. One, two, three, four. Let's see if 4 is enough. Let's make sure the orientation is correct. Yes, I mean, we're getting there. But those two are still not good enough. Man, I really screwed this one up. Well, I guess we're moving up the ladder. Maybe let's quickly try if we rotate it in another orientation, if it fits better. Nope, definitely not. Nope. Also definitely not. Okay, so this is like a unique orientation now. This needs to be in this direction. Like those two are fine, but the front two are fine. This one is so nah. Let's drill out those two with 5 millimeters. I'm an expert when it comes to drilling and stuff. But now there's so much hole, like it must align. Oh god. Okay, let's just quickly try. I don't think we are there yet, but so these two are fine. Let's see, we have an LNT. So this is fine. And this is fine. This is kind of fine. I think this one is still... Oh, it works. Okay. Whew. So instead of 3mm, we had 5, but hey. What gives? Cool. Okay. This works. Now, also I was a bit not concerned, but like this is like 2mm acrylic glass and the original one is 3mm. But it's still like the screws can go in deep enough to make up for that. So that's perfect. Cool. Then more drilling. Yay. Let's see if we can make this a bit better. So let's see if we have more luck on the second round. So let me just try to really get the center of that. First. Second. Third. And the last one. The bets are open. How horribly crooked is it? Me quickly. So let's see. This is... Oh, wow. Much better. Let me see. So we need some sort of screws. I guess like 4-6mm, something like that. Don't have any here. But I have a pot of M3x4. These are countersunk, which actually reminds me what we also need to do. Now that I cleaned up, we also need to countersink those holes. So let's quickly see how much we need to do that. A bit more. So we get like a nice flush. Let's try with one just to get like the right depth, and then we can compare the other ones against that. That makes such a mess. Like those like plastic strings. That did not go down any deeper. Let me see. If I do this over empty space, I think like the tip of the countersinking tool drill thing touched the surface. Yeah, it still pokes out a bit. And this one is lost. Yeah, something like this. It's like nice and flush. So this is now like our reference. See, last one. Let's see if they're all, this one is perfect. This one is a bit too deep almost. This one is perfect. And this one is perfect. It's like perfect flush. Cool. Okay, let me quickly. So, all cleaned up. And this goes on like this. Where did I put the Allen key? Here. I mean, if I would frost that, it would definitely look nice. Like just like using like 600 or 1000 grit and like just like sanding this like down a bit to make it like more opaque. I think it would work really well. Yeah. The last one wants to act up. Perfect. This one could have been a bit deeper. The other ones are super flush, and this one stands out a tiny bit, but... Oh, actually, yeah. I can give it another 2 turns. Cool. It is mounted. It doesn't look half bad. I mean, it's not covered. The Enderwire has like a PETG cover here, which I can also add here, like 2 layers PETG or something. Like we have this like ridge, like the bezel inside here. So we can sandwich like PETG diffuser basically in between the acrylic glass and the cable channel. Well, that would be like upgrade for later. And I mean, it's the underside, so it's like, how important is it really? So, moment of truth. It does fit, and it has quite a healthy clearance actually. Like 4-ish millimeters, I would say. And I can also show you from here, actually. Not sure if this will focus. Oh yeah, there you see it. Like this is basically like there. Cool. Perfect. Hi there, Martin. Looking around here a bit, but I really enjoyed this. Thanks. Happy to hear. Thanks for the great content live stream. You're welcome. Cool. I mean, the cabling is rather straightforward, I guess. We just have to kind of like poke it through here. Cable is now a bit shorter than I wanted to. I mean, it's still long enough. That's just on the end. Just, I mean, it doesn't really make sense to put in a cable channel that much, but just like so, it's like kind of like sorted in a certain way. Let's put it behind the Voron tube, and let's just put it up if it wants to. This cable channel is way too full. There's so much stuff in here. See if we can squeeze it in here. So, barely. Also keep it here behind the bone, actually. Poke it through here. And it's a perfect length. A perfect length. The only thing is now, you need to be a bit... That's something I did not consider, right? Like if you now put this on, or like off, you have to be careful. On the Enderwire, I have extra cable length for that. Here I don't know. So maybe it's best to not put it in the cable channel. Because then we have like another couple centimeters of extra cable length. Now it's like a bit easier to take it in and out. And you actually can also like take it on and off here, which is a bit easier, I think. Perfect. That's it. So now we can put on our little feet. Hi there, Sven. Looking forward to your final version of the underglow itself from your Switchwire. Yeah, so basically this is like the it's a different approach, right? Like the Switchwire has the LEDs facing like inwards, and then like the lights reflected down. And there I had the problem that it's not like really like nice and bright. So this one is like way simpler. It just fires straight down. It's also way more LEDs. But yeah, that is kind of like what I want to do with the switch wire as well. Just simpler to print. But then also hopefully brighter. See, last screw. Since you already have Enderwire and the 0.2, do you have more printers Vorons? No, that's all. Or perhaps planning on building more printers. Well, I would like to build more printers. At the moment, I have a bit of a storage size constraint or storage room constraint. Because yeah, I don't really have a lot of space at the moment. What I want to do, and it's kind of like a dream of mine in a certain sense, is I want to have one big printer. So I have the 0.2, which is amazing for like prototyping work, and like most things I print actually fit on here. The Enderwire is a really cool printer now because it has like 2 extruders, like for dual color stuff. Like I was printing, don't have it here at the moment, but I was printing like electronics cases. And I could like really easily have like font and like text on it with like different colors, and was like just printing it. It's super nice. Yeah, you can do it manually, but it's way more work, I think. So that's kind of also has its use case. And now what's missing from my collection is one big machine. So basically it would be like something like 30 by 30 centimeters or 30-35. Something like that. So I'm maybe looking at the Trident or 2.4. It's like, for example, like I'm kind of looking into upgrading is the wrong word, but like my PC is basically hardware from 2015. And it's kind of fine, but like it's about time next year to like have a new PC. And it would be super fun to print a PC case, like a mini ITX or M80X case. But I don't have a printer to do that at the moment. If I would have a printer in like the 30 or 35 centimeter league, I could print my own PC case, which would be super fun. I would love to do that. So maybe I have to buy or like build a printer to then build a PC. So yeah, that's kind of like my plan. But I also would love to have a second one of these little guys here. So this one has the enclosure and it has the Nevermore in the side. And this one is kind of like, for ABS, it's perfect. But the cooling is not ideal. So like the part cooling. So I would also love to have a second V0, but without the enclosure and like side mounted fans. Basically that's just like specialized for PLA. That's the best excuse to buy a bigger one. Yeah. I just put it on the PC budget. So it's a super expensive PC then, but like assembly tools is like half the price. Alex, I'm also leaning towards Trident, but 2.4 is also kind of cool. Same here, I have a V0 S1 and just almost finished a Rhetoric V-Core 3.1 300. I found on second hand for way cheaper and completely rebuilt it. Oh, that's also nice. The second hand is also an option. I mean, like, especially like if you just want the parts, right? Like you can always rebuild it yourself. It's actually like a really cool idea. And just make it yours, but then like just like discard the printed parts basically and take all the hardware. Hi there, Eduardo. Wait a Phoenix and build one, please. What's the Phoenix? Did I miss something there? I also was actually looking at I forgot the name, like the super small printer that you can fold together. I forgot the name, but the kits are also out for that one, right? Like LDO had kits for that. That would actually be also like super cool thing because like for me again, like storage space is kind of like a concern. So maybe having something that I can just fold together and put it in a drawer is also like a really cool thing. Wait, we were ready here, right? Everything is plugged in. So we are ready. Let's turn it on and see what happens. We should see some green around here. Voron Phoenix. Oh, the big one. Well, coming back to storage space. I would not know where to put that thing. I like the 300 actually doesn't take, or like the 350, 300, 2.4 or Trident, they don't take so much space. Like they take as much space as the Enderwire. But 600, that's a different league. But then I could also print like a full-scale ATX case. So maybe that's also an argument, you know, like just in one piece print the entire case. Oh, I see green. There's the green. So now the question is, if we crank up the brightness, I mean, you can see it. And again, like this is the worst case scenario here. Like you see it way more through the skirt, which also is kind of cool, to be honest. Yeah, I think they're a bit too close. Like if you lift it up a bit, it's like way more spill. So it might just be that like it's a bit too close. I mean, what we can do is, I feel like already like a millimeter or something like makes a huge difference. What we could do is we could just use like washers and like because the acrylic glass is only 2 millimeters, right? So we can just use a washer between the feet and the glass to just like space it out a bit more. Let's carefully flip it over. Looking nice. Thanks, Martin. Did you use calibration tests with your Enderwire? Mine have issues in Z-axis. X and Y are spot on. Just wondering. I did not run a calibration test. What I did notice on... Oh wait, it's actually here. Sorry, just... All right, it's actually perfect. So, I printed those on the Enderwire. Wait, let me... Let me see. Can you see it here? Okay, no, the LDs are not helpful. Yeah, you see this like ridge here, or like this like thing. So those two parts were printed separately, of course, but both of them have this like line. So this is the only thing I noticed, and this can be caused by some issue in Z. But only on those two. I think on the latest stuff I printed, I didn't have that. Another thing I noticed, but this can be down to my steppers. Not sure if you can see it on camera. Like you see this like weird pattern in a 45-degree angle going up. Like looks like vertical artifacts, but it's like a 45-degree angle. And I'm not quite sure if in the Core XZ, if that has something to do with having it in the 45-degree angle, or if that's something completely different. This is on all my prints, just like 45-degree pattern, but I'm not quite sure if that's like, I'm not really like bothered by it. It's not super visible. 1 second, my headset died. I need to quickly fix that. Here we go. Yeah, so that's basically what I noticed. Like there's basically like this one line here. Ooh. Wait. My camera arm came loose. Okay, so it's like this like vertical line here, and then like this like 45-degree pattern. Besides that, like I didn't test the sizes, but like basically what I print so far, it always fit perfectly together. I didn't have any issues. I wonder. I'm not sure which. I have a couple of cubes, but I'm not sure which one was printed on the Enderwire. Okay, wait. We wanted to take this off. Martin, this does, however, make it unable to have a small screen or macro buttons. Don't get me wrong, I like and would have that rather than screen or macro buttons. Well, I do have the button on the back, which we still need to figure out how to connect now. The screen, by the way, should still fit, because in the Fusion file where I designed it, the skirt had the screen. Like you have a lot of clearance here in front, like it doesn't impede that. So basically, as high as the PSU goes, you just have space here in front. Like there's tons of space actually. And even like if you have buttons in the front, like here, this is all free. Like there's nothing going there. So I think you can totally combine that with the buttons and screen. I wouldn't see why not. And these are even the 0.2 skirts, right? If you have the 0.2 R1 skirts, they're like a couple of millimeters higher, so you even have more clearance. Oh, love it. Thanks. That is a kit from some brand. If so, how is the quality of the parts? This is the LDO kit. I built that quite a while ago now. And I'm super happy with it. Like it's top notch. It's the most expensive kit, by quite a margin actually. Like I think I paid 700-ish euros, something like that. You get kits for like half sometimes on sale. So it's quite expensive, but it's really good quality. And the support is excellent. I actually had a problem with my Z-stepper. They seemingly had a faulty batch of Z-steppers where the lead screw would eat into the POM nut, that the nut that's basically attached to the bed. And it was really perfectly handled. Like they just sent me a replacement stepper motor, no charge, like was here within like a week, was super nice communication. So that was good. It's like, I guess kind of what you pay for is the quality and the support. But overall, like I'm really happy. And I actually have not heard from anyone who had the LDO kit who had different experiences. So I think it's definitely like one of the best kits, or the best kits. But then if you're like looking for more budget-oriented stuff, the Feistech kit exists, and Seabor, I think they're both cheaper, and also Formbot. But I don't have personal experience with those. So that should give us like a millimeter more. Let's see if this changes anything. I doubt it makes a huge difference. Oh, yeah, actually it made. You see it way more now. Way more is an overstatement, but I mean that's cool. Like it's just glowing all over here. I like it. That's definitely cool. So we can kind of include it into our macros for a second. Like I basically have like 3 macros for lights. The first one, here we go. So the first one is light off, which basically is what you see. Like this is not included now, but basically just has this as a very faint green, just like that. I see the printer has power and it's on. Then I have light pending, which actually the side ones are red. This one is red. And now this one should also be red. And then we have light printing, which turns those to white. Like everything is white actually. And also not sure if you can see it, but there's tool headlights here as well. They're also on now. So let's just integrate those lights and see what we can do. And I kind of have to read into it a bit more, but I also want to add animations, like light animations. That would be super fun. Martin, sorry for more terms. Is it blocking the LED lights? But I like it very much. I'm not quite sure if I understand, but like from like a physical perspective, you have enough space to add the buttons and the screen. But yeah, you mean like you can't see the light anymore? Yes, that's correct. Like you would basically lose that center part, basically. That is true. Cool. So let's see. I think it's actually in the macro section here. Let me see. If I say light, I'm using it all over the place, but where did I define it? Here we go. Light pending. So let's just copy basically that down. So this is, how did we now call this? I think we called it underglow. Then for printing, what do we do with printing? Which, I mean, technically everything is white, so we can also just do it white. Oh wait, on here it's not value 0, of course. It must be 0, 0, 0. And then for, oh wait, this is light pending. Light off is all 0. And for this one, for pending, let's just copy the color value we have for the other ones, which is like red 1, and then I have a little bit of green and blue in there. Not sure if that is actually visible, but let's see. Save and close. So this is now light off. Ah. How do we call it? Yeah, underglow. Oh, I know what we did, or I did. Wait, here you go. I said set pin instead of set LED. I copied this last line, which is like for the only non-RGB light. Okay, save and close. Now, light off. Still has an arrow? Oh, okay. Step by step, we're getting there. Now the parameter. Still set pin, but it must say, of course, say LED. So, save. Oh, I didn't restart. My switchwire lights are all over the place. Sometimes students like work, sometimes no. I set up is to be blue if I turn red. Well, a mess. I need to delete all light macros. Yeah, I mean, I only have the 3. I kind of try to keep it simple for now. Yeah, okay, so light off is now off. Pending is red all over, like including down here. I actually like keep it like this. And then printing is white, which I like white. White is a cool color. Yeah, I think it works for me. But yeah, I can kind of recommend like this like setup with like light off, light pending, light printing. You can also add animations to that, I think, like to those macros. But then basically like the pending just means like heating up, homing, all those. And I just added the light commands to all the macros that do stuff. So for example, where is it? Yeah, print start. So in print start macro, I just set light pending, and then when print start is done, I'm setting it to light printing. And then in the print end, wherever that is, I just set it to off. That's really all I do. It's relatively simple. Not much stuff going on. Cool. Yeah, I mean, that's a clear success. The only thing we didn't do now yet is we need to figure out where to connect that lonely button now. Like I have this macro button back here, which I use to load and eject filament. And technically, we kind of don't really need it, but I don't think I have any more free pins on the board. Like there's still like open plugs and everything, but all the pins are kind of like hooked up to something. I'm also like curious about this light here, the white one. I've never seen that. Huh? Oh, this is so cool. I've never seen that. This one copies some RGB stuff. I assume from the RGB header here, like this RGB header. If I put it to light off, it's green. If I put it to light pending, it's red. And if I put it to light printing, it's white. I've never seen that. I assume this is linked to... Yeah, to the Kirigami bed light. Yeah, if I change the Kirigami bed light, this changes. Oh, this is a really cool feature. I did not know that's a thing. That's cool. Like it very clean. I need to stop copying macros and start building my own. But can I get the macros? Yes, you can. Just remind me. Write a comment under the live stream, and then I have it in my inbox. Then I just zip up the entire thing and upload it somewhere. I don't think there's anything confidential in there. You can just download the entire configuration. But this is basically the configuration from the LDO kit. And I added this macros file. Oh, you don't see it, but I added this like macros file here with all the macros. Yeah, just write a comment and then I'll put it on my to-do list. Where also the Enderwire underglow is. Cool. Perfect. Let's see. So for this one, the easiest solution by far is to just hook it up to the Raspberry GPIO. I think we have enough wire length to do that. So if we find like something here, that should totally work. I mean, how did we now connect that? It's the outer two. So we had it on the GPIO pin, which is the blue one, and the ground. Let's see if we find something. Wait, there's this nice page. This one. So this is basically made for us, right? The bottom one, it's ground and it's GPIO 21. So this would be pin 21, I think. So let's just configure that quickly and see if we can configure that. So in the runout, let's quickly check in printer. So we basically have three main boards here, right? We have the main board here, the actual main board. We have the umbilical board, which is like up here. And the Raspberry is actually a third main board. This is here configured as MCU RPI. So what we can do is to use the Raspberry GPIO. We can configure this as RPI colon GPIO 21, right? We said 21, it should be. So let's just see if it accepts that as a configuration. It does accept it as a configuration. So that's good. So technically we can just add a DuPont on the bottom two here, and then we should be good. Let's see what our little magic crimping box has to offer. So yeah, we have DuPont. I mean, even the orientation doesn't matter there, right? And we need DuPont female twice. And that's it. So let's shut this off, of course, when we work on the hardware. Scripts like another 5 seconds and power off. Cool. Then let's try to rescue this cable here. And it's just perfect length to go to the GPIO. And polarity doesn't matter because it's just a switch. And then we can just snip off the JST connectors. And for a change, we can crimp DuPont. Okay, and DuPont, we need to use the small one. I remember. JST is the medium size and DuPont is small. So let's do one medium. And small. Yeah, that's on. But now, like, I fully optimistically only took out 2. We need 1 more. Ah, I pulled it out. At least I didn't close the box yet. Actually need to order like new crimping stuff. Slowly, surely running out. Needing 3 attempts for 1 doesn't help. Now it's on. Okay, cool. And polarity doesn't matter, we said. So we can just crimp it in on either side. That is a click from 1. See? Always like difficult to like push those silicon wires into housings. I think I put it in the wrong side. Yeah. Yeah, here we go. Cool, and let's just Put this back into the cable channel. And let it come out here. Cover this mess up again. I'm always scared working with Raspberry GPIO. It's the absolute worst because I killed so many raspberries by now with that stuff. I think this is like quite low risk. So we just have it here now on the 2 buttonmost pins. And when I press the button, they connect. One is ground and one is the GPIO 21. So let's turn it on. Nothing exploded so far. Let's give it a second to boot. It's coming online. And so basically all that should happen when I press the button now, because we still have part of the macro counted out, is it should print something in the console. So I'm pressing the button now. Oh, and it works, like out of the box, amazing. Here we go. Eject button pressed and eject button completed. So the filament run out, I can just add this back. So basically what this does is basically it checks whether it's printing. If it's printing, it doesn't do anything. If it's not printing, so if it's like not printing, then we check the filament run out sensor. If filament is detected, if yes, then we start the unload routine. And if no filament is detected, we start a load routine. So basically what I do with that is like if filament is loaded, I just press the button. At the moment, no filament is loaded. So it would start the load routine. So it would press the button and then feed filament in, and it would like just load the filament. That's kind of like how I use that. Lots of tinkering on stream. Well, you can tune in basically every Saturday. That's my little tinker session. I started that like actually with this printer, like when I got this. For me, like I never took the time to like work on stuff like that because I'm always like busy. And now since I have the stream, I really started working on like, projects like this, designing the underglow stuff. It's like, for me, just like a little bit of a help to like take the time to actually do stuff like this. And it's way more fun doing it on stream, to be honest, than like doing it on my own. So, but I think actually I need to check next week because I'm going to my parents over Christmas. So I'm actually not sure if next week stream. I need to check. I booked the train tickets a while ago. I might leave next week or the week after. So depending on that, next week might be the last stream of the year, or today was the last stream of the year. But then I'm back next year for sure. I actually have some fun stuff planned. So, I mean, the next thing, which kind of like today didn't get to it, but it's this lightweight x-axis. I want to take a bit of time for that because I kind of want to understand whether this helps or not. So we kind of, or like I want to do some measurements before, just like with the resonance tester. Then also after, to just see if we have any difference in how the printer behaves with that, or whether this is like it doesn't really help. Oh, that's the wrong screw. And they just sold you like something that looks cool. I think I lost the screw. Need to see. Okay, somewhere is the screw. For now, this has to suffice. Okay, let's see. Where is the lost screw? I dropped one, but it was a different screw. Oh, there's the one I dropped. There's the one I dropped. So, I mean, that's also good. Most likely I'll find it when I clean up. I guess it's not super important. That will find its place. It's just like the panel clip down here, so it's not the essential part. Let me quickly tighten this one here. And then I would say this is a success. Let's quickly save and restart that the macro is saved. And then, yeah, this is then for next week or January, depending. And this replaces this extrusion here, which is like a normal aluminum extrusion at the moment. And this one is supposed to be much lighter. I mean, it is much lighter. And then hopefully this results in a little bit more like acceleration capability in the tool head without having ringing. Let's go. I was looking into buying the light rig entry as well, but since everything is already so small, it would make not much of a difference. Yeah, that's kind of like what I figure as well, right? Like, how much can this make as a difference? I got this now on Black Friday for like 15 euros. And I was like, okay, whatever. Let's try. But yeah, for a red rig, like on the bigger printer, it definitely makes a difference, right? Like, because the extrusion is so much heavier. But here, I'm not sure if that is... Like, I'm count me skeptical. But yeah, basically what I want to do is I have a scale, so let's see what the difference is. And then I would just run the resonance tester before in the current setup, and then run it with the lightweight gantry, and then we can just see like how the printhead reacts to the resonance, right? So does this make any difference or not? Cool. Minus the lost screw, I would say this is a full success. Wait, we're missing the door. We are missing the door. Can't end without the door. Door assembled. Cool. Then thanks everyone for tuning in. For that cheap, I would have bought it as well. Yeah, it's looking cool. So it's definitely like, that's kind of like my thing, right? Like, if it doesn't help anything, it at least looks cool. So, but yeah, it's like, just check on AliExpress. Like, sometimes you get them on discount. So that's it. Cool. Okay. Then thanks for tuning in, everyone. And then see you next week or in January. I'll make a post on YouTube before next stream. Cool. See you. Have a nice weekend. Oh, and my shortcut is broken again. Now, see you.